and share my screen. I'll start right here. Okay, good morning, everybody. Welcome to our start of hacking for the week. Today we're going to do a transition from talking about web pages, things that you can directly view and look cool, to something that's going to, at least at the beginning, start out significantly more complicated, talking about Python now instead of HTML and CSS. So we'll get to that here in a little bit. Before we do that, just some quick updates, announcements for that first lab. Again, no late penalty on that first lab, but 8 students still have not submitted it. And if that happens to be you, then you should consider yourself a little behind at this point. So make sure that you get whatever you need worked out on that so that you can submit it. The project, again, the lab is sort of part of the project. You can't complete the project without completing the lab. Technically, the project had a due date of yesterday at midnight, and so there's 5 submissions already. But 100% okay if you haven't submitted yet, because if you collaborate with anybody else in any way whatsoever, whether that means going to the QCL or meeting with people in outside of class here, also taking CS40, or whether it means talking to your computer science major friends at Mud or Pomona, however you're collaborating with people, as long as it's somehow in-person, face-to-face collaboration, then you automatically get a 48-hour extension. You don't have to email me. You don't have to ask for it. All you have to do is, in your Sakai submission, tell me how you collaborated with people. And one of the reasons why I just want to see this in Sakai is so that I can get a sense of how you all are collaborating, and if it's, so I know what's being helpful for you. Any questions about the project due date? Anything like that right now? Question is, where do you put the collaboration information in Sakai? And the answer is, there's a text box where you put your link to your website. You just link to the website. Right below that, I collaborated with whatever. Good question. Any other questions about the project? Okay. As an aside, if for whatever reason you do email me, and there's lots of good reasons to email, or as you're posting things on GitHub, in the hacker world, computer world, we all are very informal. So I definitely go by Mike on GitHub. If you wanted, you can also call people by their usernames on accounts. So you could say @MikeIsBicky. That's also 100% okay. But make sure that proper punctuation and capitalization, things like that, still very important. We're informal, but we're going to see today especially that small details really matter about things in programming languages like Python. And because of that, people who do programming languages a lot they're sort of the original grammar Nazis. I'm very particular right here, for example, about putting this period outside of this quotation mark. Most American English writers would not do that, but I want to emphasize that this period is not part of this quotation right here. It is something outside of the quotation. So people in the English department who are Americans might do that, but hackers always follow the British style of punctuating periods outside of quotation marks, because that's what actually makes sense. The period's not part of the quotation. So yeah, we'll see lots of examples today of just a single character in the wrong spot totally messing up your code. And so those sorts of details still matter. Quiz. So today, all the stuff we talk about today will not be on the quiz that is this coming Wednesday, 2 days from now. We've already covered everything for that quiz. And today is totally new material. Today, we'll be talking about, we'll be talking about Python, and there is practice quiz material, that big packet of stuff. We won't talk about exactly what the quiz format looks like, but we'll be going through some of those problems today, and the quiz that's related to those problems will be a week from Wednesday on the 21st. Before we get started with the material, any questions about anything administrative in this class? Okay, so Back over to GitHub on our CS40 repository. These main web pages for your projects, again, called repositories, are storing our class as a repository, as a project on GitHub. In this topic 2 Python control flow, that's where we are this week. And scroll down. I asked you to do a handful of things for class today. If for whatever reason you haven't done them yet, then you'll still be able to mostly follow along, but we will be using Python in class today. So if you don't have Python on the computer you're using, then there'll be about 5 or 10 minutes that you won't be able to follow along with. But we'll also be using Python through a web page that you will be able to follow along with. And then these pre-lecture videos, if we'll be talking about all of these concepts again in class today, in particular as they relate to the questions on the practice quiz material. But these are good things to, if maybe things aren't 100% clicking after your first watch of this video or after class today and class next Wednesday, this whole week we'll be going over this material, then watching these videos multiple times can definitely help. Scrolling down, also, so our textbook, we're done with that HTML, CSS textbook for the semester, and we're going to be moving on to this automate the boring stuff. Oops, and that is a typo right there, not the boring stuff. The boring stuff, very famous textbook in the Python world, probably the most famous Python book there is. And we're going to be going over chapters 0 and 3. So if you click that link and maybe the videos weren't quite working for you that I gave you, or the video or of this class lecture today not quite working for you, and you want something maybe printed to follow along with, these chapters right here are what you can take a look at. And again, QCL is going to be a great resource for especially this beginning Python stuff that there'll be lots of people at the QCL who can help with these resources. Any questions about any of that? Okay, then jumping over here to the Python cheat sheet. We're going to want to have this out in front of you where there's a lot of information on this. It can feel very overwhelming at first. But again, you're going to be able to have this with you with the quiz that you'll take, your first Python quiz next week. And so it's good to have this anytime you're doing any sort of programming or in class, having this side by side so that you can reference exactly what is going on with the code and where it fits into this cheat sheet. And as we go over the problems on that practice quiz material, I'll be jumping back to this cheat sheet and highlighting where the information related to that particular quiz problem is on this cheat sheet. But we're not going to go over all the information in this cheat sheet in this first week. This is probably like 6 or 7 weeks worth of the next coming Python material that's all contained here in just 2 pages. This quiz practice is what we'll be going over today, and sort of the way that I think about learning Python, I think about it similarly to learning a foreign language, where you have to learn both to read and to write. And so the quizzes are going to be focused on reading Python, and that's what we're going to be focused on today, is not necessarily writing your own Python to do stuff, but reading Python that somebody else has done and figuring out what it does. The next about 2 to 3 weeks in this class is going to be very abstract, and maybe the applications won't be immediately obvious. After that, we'll be getting into lots of the very cool applications of all this stuff. Again, if you're taking, say, like CS5 over at MUD, other intro Python courses, basically everything is this level of abstract, but we'll be moving away from just this purely abstract stuff to the practical stuff in about 3 weeks. So you have to get through this. If you're interested in that practical stuff, you have to get through this purely abstract stuff at the beginning, and then we'll get to the practical. Okay, lots of prefacing stuff. Now we're on to over here back in VS Code, and we're going to actually start Python, run a couple small Python programs, and start on those quiz problems. Again, if you don't have Python installed, then there'll be like 5 minutes here that you won't be able to follow along with. Just sort of pay attention, get the high level idea, and then we're going to switch over to a web page in 5 or 10 minutes where you will be able to follow along with. Okay, so over here on the left-hand side, I've opened up my CS40 project folder over here. I have my topic 2 folder right here. I'm going to create a new file inside of topic 2, and I'm just going to call it monday.py like that. Open up monday.py, there we go. And there it is. With HTML files, we call things .html. With Python files, we do the .py at the end. And the simplest, one of the simplest Python programs you can do is printing just the string hello world like that. Again, you'll always have to, anytime you have the white dot up at the top, always remember to save it. Press Control-S right here to save it. And then anytime you want to run your Python program, just like when you want to run something on your DVD player or running anything, it's that triangle button up here in the top right, runs it. And if you don't have this bottom window open, it will automatically open it for you and show you the output of your program. There's a bunch of extra sort of stuff here that's going to be different for depending on everybody's computer. This will all be different, but then it's going to have the output of your program right here. It says hello world. And so this print command up here just printed out hello world for us. So again, steps that I've done so far, I just created a file, right click, new file, and I named it something .py. So I called it monday.py up here. Print hello world is what I typed in over here. Press the triangle button and it runs it. Again, all of this, there's going to be a lot of extra information in here besides the output of your program. That extra information is going to be different depending on everybody's computer. But you should also see the output of your program, hello world, in there somewhere.
My computer does not have the green triangle.
Question is, if your computer does not have the green triangle, then there's a lot of potential reasons why that could be the case. But fundamentally, what it means is that VS Code is not linking up to Python somehow. And so I'll have to take a look one-on-one with people to figure out exactly what could be causing that. But again, you'll be able to follow along with class today because we're only going to be in VS Code here for just another minute or two. Yes?
Oh, I was just gonna add, should we switch to like Python's launchpad instead?
Nope. So yeah, just yeah, we're going to be switching to another thing that everybody will have access to here in a minute. And then on Wednesday, hopefully everybody will have their VS Code set up. Good questions. Any other questions so far? Yeah, the question is, how did VS Code know it was a Python file? And it's this .py at the end. PY for Python, and that's how VS Code knew that it was a Python file instead of an HTML file or something else. So one of the differences between Python and HTML or CSS is that Python, we can do computations. And I'm going to switch over here for a second to this problem 1, and I'm just going to type this problem number 1 right here into my monday.py file. So somebody help me out. It was x equals 2/3/3 y equals x star 4, y equals x star 4, z equals y plus 5, z equals y plus 5. And then there's this print z equals z, print z equals comma z, something like that. And if I go ahead and run this, pressing the triangle button again, then it still does the print hello world up here. And then Python steps through, does these math computations, which we'll talk about here in a second, and prints out the results. And down here, the result of those particular math computations happen to be z equals 5. On all the sort of lab problems, project problems in this course. We're going to be typing code into VS Code like this, and you'll be running things inside of VS Code. For your quizzes, though, and for just reading Python code that somebody else has written, understanding, like, given some Python, what is it actually doing? We're going to use this web page called Pythontutor.com. And so we're going to switch over there right now. So here I have it opened up. The web page is Pythontutor, Pythontutor.com. And if you go to this web page, you'll get something that looks like this. And you click this button at the top, says start writing and visualizing code now. Click that, and you'll get a little text box right here. This is where you can type in Python code. For the purposes of these quiz problems, you put the quiz problem in here like this, and that's what you do. But this sort of box right here, this box where you type in code, is like, you should think of it like a Python file that you're typing in, like something inside VS Code that we were using this triangle button to run. This is going to be the same exact thing. We'll get the same exact output as if we put it in Pythontutor.com and run the code in here. The difference between VS Code and this Python tutor is that Python tutor is going to sort of break the code down for us step by step, and we can see exactly what each line is doing. And so it's more helpful for understanding things. Are there any questions about how to get to this screen with Pythontutor.com and get the problems inserted? The question is, say the link again. It is Pythontutor.com. Maybe easier to see down. Pythontutor.com. This is the link that you want to visit, and you'll be able to use Python directly from your web browser this way. Any other questions so far on the setup? Yes. Okay, let's pause that. So the question is now, like, how do we actually run this? Where do we see all the results? And the answer is this visualize execution down here. You press that button, and it's not going to run your code yet. It's going to take you to this window over here. If you want to actually run this code, then there's this next button down here. And the next will walk you through one line at a time exactly what Python is doing on each one of these lines. So there's 4 lines here. So press this next button the first time. The red arrow indicates the line that's about to be executed. So as soon as I press next, it's going to execute this red arrow right here saying x equals 2//3. Press the next button, and then Python goes on to the next line. If I press the next button again, it'll execute this line 2 right here. The green arrow indicates the previous line that was just executed. So basically wherever the red button used to be, wherever the red arrow used to be. And there's this helpful little key down here that helps you remember that. So when Python encounters this line, any line actually with an equal sign, what it's going to do is you're going to see this box over here be created called the global frame box under frames over here. We don't need to, at this point, frames, global frame, objects, those are just magic words for us right now. We don't care what they are. But the important part is this part right here. Anytime you have this equal signs, the thing to the left is called a variable. And the name of that variable is going to appear over here inside the global frame. Whatever you have to the right of the equal sign is going to be assigned to the value of that variable. In this case, this 2//3 happens to be equal to the number 0. This computation right here, which we'll talk about what it is in a second, happens to compute the number 0, and so it stores the number 0 right here. I'm going to go back to editing this code for a second, and we're going to just change this. So this is a different problem now. We'll just see what happens. Something a little bit simpler, x equals 2. Visualize the execution again. And now if I press the step, x equals 2, something simpler, you can see that the 2 is just stored right there. Back to edit this code. 3//4 like that. Visualize execution. Okay, we'll talk about the details of what these operators are doing here in a second. Right now, we're just going over how to interpret the screen. So yeah, we're on step 1 of 4, haven't done anything, press next. Now we're on step 2 of 4, we've created this X variable over here. If I press next again, it'll execute line 2, creating that Y variable over here. Y also happens to be equal to 0. And then I press next one more time, executes line 3, creating that Z variable. Again, anytime you have something to the left of an equals sign in Python, it's going to do something to this global frame, creating that variable over here. And so now this new computation stored the number 5 inside this Z variable. And so when I have this print Z equals comma Z, again, this line has not executed yet because the red arrow is on this line. But when I press next one last time, it's going to execute that line. And up here, you can see that it says Z equals 5. And so this is the output of this problem. And this is what you, on the quiz, my expectation for you to get full credit on this problem is that you would write just Z equals 5 right here. And if you have that, then you'll get full credit. If you did not have that, then you would not get credit for the problem. So there was the question before of where does the output go when you have a print statement inside of Pythontutor. The output comes into this box in the top right over here. This box in the top right, if we compare it to the VS Code, is equivalent to what's coming out down here. And then this box on the left was equivalent to the file, the monday.py. And the new stuff is this stuff over here, which gives us the internals about what's going on. Any questions about any of that? How to read this file? Yes. So the question is, in VS Code, where's the output? The top up here is the input, the actual Python. You press the triangle button and the output will appear down here on the bottom. Yes. So yeah, we haven't talked about what this program means at all. All we've talked about is how to interpret the display here. Yeah, so all of these are math operators right here. And so the question is, like, what are these math operators doing and how do you do this on the quiz? And so what this first problem on the quiz is really testing is, do you understand what these math operators mean? This corresponds to, on the Python cheat sheet, there's this box down here in the bottom left labeled maths. And you are going to be responsible for all the information contained in this bottom left box for the first quiz. These operators right here show the different math operators that you can do: plus, minus, star, slash, and so on. And for the most part, they do what you might expect them to do: plus and minus. The asterisk right here, I'll zoom in a little bit, there we go. The asterisk multiplication. A single slash is division, like you might expect it to do. But the 2 slashes, what we have in this particular problem, is what's called integer division. So what is integer division? Well, we could say, if we wanted to find out, we could go to the Python, all those resources like the textbook, and it'll tell us. But we're computer scientists. Scientists run experiments. So let's think about how can we run an experiment to figure out what is integer division compared to regular division. So I'm going to edit this code, and let's just try something, change something around. Let's try this 3/4 like that. Save this like that. Whoops, sorry. You don't have to save anything when you're in pythontutor.com. All you have to do is press this visualize execution down here. And now when I press the next button right here, the result of this computation, 3/4, is stored over here. So 3 divided by 4 is equal to 0.75, and that's what's stored in the X value right here. Anytime you have the single division sign like this, this is division like you know and love from all your previous math classes. Back to, I don't know, 5th grade, third grade, whenever they talk about division. I don't even know. Integer division is like division, but it takes away everything after the decimal place. So integer division, in this case, will only give us the 0 because only the 0 is in front of the decimal place. Let's edit this code again. Let's change this. Let's try 4/3. So there's a single slash, so it's normal division. Actually, let's try 5/4. There we go. 5/4. So 5/4. It was 3/4. Now we're trying 5/4. Visualize that execution. Press next, and we get 1.25. If I change this slash now to the integer division slash, the double slash, 5/4, visualize execution. Press the next. Now we get a 1 because the answer previously was 1.25. Take away everything after the decimal place, only giving you the integer, and you get 1. This does not do rounding. So when we had 3/4, that's 0.75. If we were to round that, then that would round to 1, but it doesn't round. It just takes away everything after the dot and gives us the 0. So that right there evaluates to 0. X times 4, x is equal to 0 right here. So anytime you have a variable in your math equation, then this variable, you substitute whatever value is over here into that formula. So substitute 0 for x, we get 0 times 4. Anything times 0 is 0, so y is going to be equal to 0, y 0, like that. Now we substitute anytime we have a variable in our formula over here, we look up in this global frame box what the value of that variable is. That value is 0, so substitute 0 in for y. 0 plus 5 is equal to 5, so z is going to be equal to 5. And print that out. Z equals 5. Any questions about the meaning of those math operators? Okay. Back over to, here we go, the quiz material. If we look at this next problem down here, so this we just typed in problem 1, saw that z equals 5. If we look at problem number 2 down here, you see that there are some different math operators. Maybe there's a percent sign right here, maybe something that you haven't, have no idea what it does. I'm not gonna talk at all right now in class about what it does. I'm not going to talk at all about what it does before your quiz. My expectation is that you're going to look it up in the material, whether it's those pre-lecture videos or whether it's the textbook, and try to figure out for yourself what that percent operator is doing. And then again, once you think you know what it's doing, the right way to work on these problems, try to predict what each one of these lines is going to be, and type it into Pythontutor, see if you're correct, and that's how you can test your own understanding. Any questions about that? Okay. The next few problems down here are if you have lots of math operators going on, then how does Python know which ones to do in what order? And the answer, if we come back over to our Python cheat sheet, in this math box down over here, in this bottom left spot over here, it says the usual order of operations. So if we look at this star, for example, the 2, like double multiplication, that's equal to exponentiation. This the things right below hand are telling us what these symbols above mean. So star, exponentiation, that's always the most important thing, followed by our multiplication division, followed by plus and minus. And so where did I go? Over here. Over here, when you're figuring out what these are going to evaluate to, you would have to first do the, say, the exponentiation here, then you would do the multiplication, then you would do the addition. So normal order of operations things. very common for students to miss points on your first Python quiz just from making like a brain fart about what your order of operations are. So make sure that you understand these two problems here and understand the order of operations. If you have a problem like that on the quiz, it should hopefully, the intention is that it's a super easy one, but you'll just have to make sure that you remember the right steps to do for order of operations. In terms of like on the quiz, when you're evaluating things by hand, you'll notice that all of these numbers are like super small numbers. You should be able to do all of these like math problems in your head or small amounts of pencil and paper to keep track of intermediate steps. There's not going to be anything crazy going on. Excellent.
The modulo operator, what order does that flip for does that count as division?
Say that again.
For the modulo operator or the remainder operator, does that count as the saying the order of operations? Like, where does that count?
So the question is that, okay, I know my order of operations for exponentiation. I know it for like division and plus and minus, but where does this fit in? And the answer when it says like priority right here is you always do basically go right to left. That it's the star is the most important thing. All of the multiplication division-ish things are all equal to each other, and then plus and minus equal to each other. The Jasmine question?
Yeah, what does the little
Question is, what does the percentage thing mean? And the answer is, I'm happy to tell people that after you look it up. And so happy to answer specific questions about, I've looked up what this means, and I'm not sure what this sentence is trying to say, but I want you to get the practice of looking things up. And so I'm not going to explicitly say it in lecture. And this is going to happen throughout the course a lot. By the end of the course, the goal is, I mean, there are certain concrete things that I want you to know, but really the goal is that you'll be sort of self-sufficient in terms of being able to program by yourself. We're not going to be able to cover every programming concept in this semester. And so you'll need to be able to like be comfortable with this ambiguity of having to look stuff up. And so this practice with that. So you'll have to look up what this percent sign means. It's going to 100% show up on the quiz. Great question. Any other questions so far? Okay. So back, I keep switching away when I need to click up here. Let's go down to, I want to do problem 6 down here. And so the problem 6, what makes problem 6 unique is it has these what we call control statements of if and else. And so we're going to walk through in Pythontutor exactly what those look like and how to interpret them. Again, this practice quiz is something that you can have available out in front of you while you're working on the actual quiz. And so taking notes on these problems, whether it's the problems we're working on in class or these other problems which we're skipping over, which you can do yourself. This is a good spot to take notes. I added lots of white space here so you can take notes so that on the real quiz, when you see a problem, you can say, oh, that looks like problem 6. I'll go to problem 6 and see what my notes say so that I know what like the tricky edge case things that I have to think about are. Okay, I'm going to type this in now into, here we go, edit this code. So x equals 4 minus 5, y equals 5 minus 4. I think that's the right order. And then if x equals 1 and y equals 1, colon, result equals 0, else result equals 1, result equals 0, else result equals 1, print result equals, comma, results, like that. I think that's the same same thing as problem 6. If at any point I do make a typo up here and you catch it, definitely make sure to point that out so that what we're going over is the same as what's printed. again, step through this one line at a time down here. And if we have an equal sign over here, a single equal sign. So x equals 4.5, press the next button. It evaluates 4 minus 5. We get -1. Negative numbers, totally fine in Python. Y equals 5 minus 4. Next. And we have x is equal to -1 and y is equal to 1. Here we have an if statement. And for an if statement, what it's going to do is this right here is called the condition of the if statement. Again, these vocabulary words are not things that you have to memorize at all, but I'll be throwing them around. So it's good to just have a sense of what I'm referring to. This right here, again, is the condition of the if statement. And this right here, we would call the body of the if statement. And so what we're going to do is we're going to evaluate this line right here. And if this turns out to be true, then we'll go inside, do this command right here. If the condition turns out to not be true, if it turns out to be false, then we will do this line down here. And so what we're going to do, we're going to print the results. The results will depend on whether this up here turns out to be true or turns out to be false. These conditions can get extremely, extremely complicated and very hard to like wrap your mind around. But for the most part, they follow like basic logic like you think they might, like you would hope that they would follow. And so here we have x double equals sign 1. The double equal sign means that we're actually checking to see if x equals 1. We're not assigning x to be 1. The single equal sign means that we're assigning x to be equal to this value. The double sign means that we're checking is x equals 1. So the doubles equals is like a question. The single equals is a statement, a command. Set x equal to 1 is x equal to 1. In this case, x is not equal to 1. It's equal to -1. So when we do this right here, -1 equals 1. Again, every time we have a variable, we substitute in the value that we see over here. We see -1 double equals 1. That's not true. -1 is not equal to 1. So this right here is false. And so this whole statement is going to be false. And we'll go inside, run this command right here. I'm going to press the next button, and we'll see if that's the case. Press next. And oops, did I press it twice? Oh, yes, I apologize. This command, this statement up here was false. So we do not do this. We do the else. We come down here, do the result equals 1. So normally when we saw before, the green and the red lines were the green and the red arrows were right next to each other. Now, however, it jumped down here to result equals 1 because this up here was not a true statement. So we did not execute this. We came down here, and this is what we're running. Set result equals to 1. When I press next, it's going to run this line because this is the line with the red arrow. Press next. It runs that line. And down here, we set result equals to 1. So when we print results, result equals to 1 like this. If I were to change this condition up here so that it evaluated differently, let's edit this code. Change this so that, well, x was actually equal to -1. So if I do this, visualize that. Now this condition right here is going to be true because x is in fact equal to -1 and y is in fact equal to 1. We're going to go inside of here instead into this block. Press next. The red arrow comes here, and we'll set results equals to 0. We'll jump across all of these things. We're not going to execute them. Jump down here to line 7 and run that command, print result equals results. And there's the final output for that modified problem. Are there any questions about how to interpret the if statement? Yes. Sorry, can you say that again? So the question is, where are we specifying a formula over here? And the answer is there is no formula. If we edit this code again, up here I happen to have a formula, but I could just as equally say x equals -1 and y equals 1. If there's a formula, Python will evaluate that formula and store the results in this variable. If there is no formula, then Python will just store that number into this variable right here. Visualize that execution. And even though there's no formula over here, it just says x equals -1, so it does it. There's no formula right here, so when I run this line, it'll just store the 0 in that variable. I could add a formula there. I could say something like 3 times 4, and then it would evaluate that formula for me. When I do the result equals, it'll say, okay, 3 times 4, that's equal to 12, and store 12 in result. So to the right of the equals, it can be whatever you want it to be, whether it's just a number or some super complicated formula. Yeah.
So which results for line 7 is referencing just the text result versus the
Yeah, this is a great question. The question is, here we haven't seen this yet. There's 2 lines here that set result equal to be some value. And so the question is, how does Python know which one of these results it should be using? We have 2 variables, they're assigned to 2 different things. And so how does Python know which one to use? And the answer is that this condition up here tells us which one of these results we're going to use. If this condition is true, then you always do what's inside the body of the if statement. If this is true, you do this. If this condition is false, then you do this. In this case, x equals -1 and y equals 1 is true, so that's why it did this. And then you'll see that the red line is going to skip over, this red arrow is going to skip over the 5 and the 6, go down to the 7, because this is only going to happen when this condition is false. This condition was true, so we skipped over it. If I change this, edit it again, change both of these to be equal to 1, so now this condition is going to be false. Visualize this execution. Step through that, and it's false, so it does not do this one. It does this one instead, sets result equal to 1, result equal to 1 over here, and then prints it out up here, result equals 1.
And what does the single quotation do on line 7?
Question is, what is this single quotation mark on line 7? And the answer is when you use this print, I haven't used this word yet, but this print function. A function is anytime you have parentheses next to a word, that word is a function. Anytime you use this print function, if you have things in single parentheses, so if you have text in single parentheses, or we would, the Python word for this is a string in quotation marks. If you have a string in quotation marks, it'll display that string up here. So results equals like that, and then comma, the other things that you want printed out. So here, result is a 1, substitute the 1 into this spot right here, and it prints the 1 right there. So that's why the output is result equals 1, because of the print statement right here. Why?
On the actual
Question is, on the actual quiz, what should you actually write? And you'll want the output to match this exactly. Yeah, in a little bit here, there are some of the more complicated examples will have more complicated output over here, where the meaningful output is more than just a number. And so writing the output exactly will guarantee that you get full credit. If all of this feels like there's a lot going on, then that's okay. If this is feeling a little bit overwhelming, that's okay. Just watching those, again, the pre-lecture videos will reinforce a lot of these concepts about things that maybe are not fully clicking right now. And just going through all these problems, going through the previous and the next, walking through all these steps will help cement what all these things are doing. Question? This result equals corresponds to this result equals this result here, because it's not in a string, is going to get the substitution happening, and we'll get the 1 up here. Yeah, because this is inside of the quotation marks, we don't interpret the process of substituting the values over here is sometimes called interpretation. We don't interpret the things inside of strings, we just print them exactly as they are. The things outside of strings get interpreted by Python, and so it does that substitution, does whatever math needs to happen, and computes the results. And in this case, that's just a 1, so it prints 1. All great questions so far. Any other questions? Yes.
On the quiz, will we just have to find the results and would we have to write?
Question is, on the quiz, what do you have to write? My recommendation is that you would go through these intermediate steps of like substituting values so that you have a reference as you're walking through. Certainly, if I were doing that, that's what I would be doing. I would be writing out, okay, what is x equal to at this line? But then the thing that's actually going to be graded is if your output matches what's in this box, you'll get full credit on the problem. If it doesn't match what's in the box, you won't get full credit. Okay, so yeah, let's talk a little bit more about these conditions inside of if statements here. Here I have the x equals -1, y equals 1 like this. And most conditions inside of if statements are going to look something like this. I'm going to type in some stuff just by hand here, and then we'll jump to the next problem. Problem 7. So I'm going to edit this manually. And in Python, so we've seen numbers like this, numbers without decimals called integers. These are integers in Python. And Python also has another type of variable. So type, an integer is an example of a type. A string right here is an example of a type. Another type is like a true or a false. These would be called Boolean types. So we can say something like if true, like this. I'm going to say z equals up here, x equals 1, and y equals we have -1 like that. I keep hitting Control S. So what I did was this used to be inside of the condition. I moved this condition out up here, assigned it equal to a variable, and I'm saying if z like this. This thing over here to the right of the equal sign is now going to be evaluated. Python is going to check, is x equal to -1 and y equal to 1? And it'll assign that, whether it's true or false, to this variable z right here. Let's run this, visualize that execution. Press next, run line 3. Actually, right now, well, x is not equal to -1, so I expect this not to be true, but to be false. So z down here is stored as false because this condition up here was not true, it was false. X is not equal to -1. And so now here I have if false. False is false, so we're going to run what's inside the else statement down here. Result equals 1. If I change this again, set that equal to 1 like that, visualize this execution. Next. Evaluate this up here, it's going to evaluate to true. And now if I have if true, whatever's true over here, whenever this condition is true, we're going to go inside here, run that code block, result equals 3 times 4, we'll get 12. So the point of this is that this true and this false are what's determining whether we go inside the if statement or not. Most programming languages, there's only true and false. In Python, though, Python has what's called truthiness and falsiness. So Python has truthiness and falsiness. And if you're a Colbert fan, you've heard him use these words before. Python's been using them for 30 years, so long before Colbert. And if a value is truthy, we're going to go inside the if statement and run it. If a value is falsy, we are going to go inside the else value and run it. So here, let's see, is the one value truthy or falsy? We'll know it's truthy if we run this line. We'll know it's falsy if we run this line. Visualize execution. Step through this. And here we had this line up here. If one, like this, so this is a truthy value. We know it's truthy because we're going inside here and running this statement right here. If one, do this. If this was falsy, we would do this down here. So let's see something that's falsy. If 0, visualize execution. Run this. Now we're going to go to the next line here. If 0, 0 is falsy, so we go into this else statement down here. Falsy, run this line right here. The truthy falsiness, again, something that's unique to Python, but there's a lot in those pre-lecture videos that are going into detail about the idea of truthiness and falsiness. So good resource for that. Freya, question.
Is there any time that like it could be false with the if, then it would do that computation, and then if it was true, then it would do the else statement. So it would be like the reverse.
If this thing up here is true, evaluates to true, then it's always going to do this. If this thing evaluates to false, it's always going to do this.
There's no way to swap it.
So again, programmers in general, super precise technical people. So the precise technical answer to the question, is there no way to swap what an if statement does? The answer is there is never a way to swap what an if statement does. If the condition is truthy, it will always do this. If a condition is falsy, it will always do this. But I think the question you're trying to ask is, if I have a condition, how can I swap the truthiness value of that condition? So this condition right up here is currently evaluating to true because we have 1, 1, x equals 1 and y equals 1. Let's now do, so we have x, y, z. Let's do an a equals not z like that. And we'll see what's going to happen. Visualize this execution. Z evaluates to true. Z evaluates to true right here. And now when we have not z, true is truthy, so not is going to swap the truthiness value. It's going to change it from true to false. And now this variable right a here, a is false. And so when I run that, it's not going to do this, but it's going to do this instead. So if you want to swap your truthiness value, which will change which body you run, whether it's the if body or the else body, then you can put a not in front of the condition like that. This whole thing can be equivalently written by saying something like not x equals 1 and y equals 1 like that. So here was our previous condition, putting the not in front of it, needing parentheses for order of operations reasons. Visualize that execution. Next, next. Now here, we're not looking at the a and z values, but this happens to be exactly equal to a. Press next, and so it'll be evaluate to false and do that. Great question. Any other questions? Yes, Mark. Question is, what if neither of those are true? What if neither of what are true? So if you have something that is falsy, if this were falsy and you apply a not to it, you're guaranteed to get something truthy. So yeah, I think I know what you're trying to ask. Hold on to that question for a little bit later, though. So what this is leading us to, this problem 7 right here, we have a different type. Now we have quotation marks here. We saw previously how numbers are treated true and falsy, that a 0 is falsy, every other number is truthy. What about for the string types? The quotation marks right here. Quotation marks are going to be evaluated as falsy if the quotation is empty. If the string is empty, that is falsy. Any other string is going to be truthy. Let's edit this code, make it look like that problem. Results, we have 0 on top, 1 on bottom, 0 on top, 1 on bottom. So there's now problem 7 right here. Visualize the execution. And you can see that it's just jumping straight away down to here because this quotation mark is empty. It evaluates to falsy. So result's going to be equal to 1, and it prints result equals 1 up here. If I edit this code and change this string to be anything else besides the empty string, doesn't matter what it is, visualize this execution step, and this is now a truthy value. If I have the string that contains the word false inside of it, again, anything inside of quotation marks, we don't actually evaluate. Python never looks inside of quotation marks. And so it doesn't look at this false and say, oh, false must be falsy. It just says, this is a string. This is not an empty string. So this is a truthy value. And so it did result equals 0, printing out result equals 0. On the quiz, there's definitely going to be something about truthiness and falsiness because Python programmers, for whatever reason, love having if statements that are counterintuitive like this, using truthy and falsiness. And so this is something that definitely 100% have to have mastered. And again, all of this, like if you want more details of truthy and falsiness, all in those pre-lecture videos. Any questions at this point? Okay, let's jump down to problem 9 over here. 9 is introducing this new idea of the while loop. So I equals 0, totally fine. Edit this code. I equals 0. There we go. Total equals 0 while I less than 5. Total equals total plus I. Total equals total plus I. And then print total equals total. Print total equals comma total like that. And visualize the execution. And now, so a while loop is like an if statement in that it has a condition after it and a body down here. And so these first lines run, oops, did I mistype this? Apologize. Problem 9 has a typo in it. This should be, it's meant to have 2 lines inside of it. I equals I plus 1 down here, and then the previous line. So I'm adding this line 5 to the problem, and we'll see what happened there in a second. But this is my the code that I'm running. I press next. I'm going to evaluate line 1 right here because that's where the red arrow is. Press next. When I evaluate that, I get my new variable over here, I, set it equal to 0. Now I press next again, get this variable total, set it equal to 0. And now we have this while statement. A while is just like an if statement the very first time you encounter it. It's like an if I is less than 5. Well, I is in fact less than 5. I is equal to 0. 0 is less than 5. It's true. So we're going to go inside the body of the while loop. Press next right here. And it's going to go inside the body of that loop. Now it's going to run the total equals total plus I. Total equals total plus I. I is currently equal to 0. Total is equal to 0. So I'll add those together and set total is still equal to 0. Here we have I equals I plus 1. And it substitute I over here on the right-hand side. 0 plus 1. that's equal to 1. Put that into the value for I over here on the left-hand side. We'll change this value from 0 to 1. Press next. It changes it from 0 to 1. If this was an if statement, then we would go down here to line 6 afterwards. But because it is a while loop, we go back to the condition and reevaluate, is that condition true or not? So a while loop will go back here and redo the same thing over again. I is currently equal to 1. So 1 is less than 5. Go through, do these lines. Total equals total plus 1. Total equals total plus I. The I was equal to 1. Total was equal to 0. So that's why total is equal to 1 now. And I equals I plus 1. I is currently equal to 1. Substituting a 1 right here. For this I, 1 plus 1 is equal to 2. Store that in the value of I right here. So when I'm currently on line 5, I'm going to press next. I'm at the very last line, the last statement of this while loop. Whenever you're at the last statement, the very next line that the red arrow is going to go to is the condition line up here, line 3. And it's going to, as I do that, substitute again 1 in for the I. 1 plus 2 is 2. So I will be set equal to 2. Press the next button. You can see that the I changed over here to 2. The red arrow moved up here to line 3 with the while loop. Re-evaluate this condition. 2 is less than 5. Go through, update total equals total plus I. The right-hand side is equal sign. Total plus I. Total is 1. I is 2. 1 plus 2 is 3. Set that equal to total over here. Total is going to be equal to 3 after I press next again. Going down here to line 4. I equals I plus 1. I equals 2. Substitute 2 in right here. 2 plus 1 is going to give me 3. Put the 3 into the I. That'll change this 2 to a 3. Next. Do this again. We'll go through, almost done here. Total equals total plus I. 3 now plus I is 6. 3 here gives me 6. So total is going to be equal to 6. Total is equal to 6. I equals I plus 1. 3 is going to change to 4. Back up to the while loop. 4 is still less than 5. Go in. Total plus I. 6 plus 4 is going to be the right-hand side of the equals. Set that equal to total. It's going to be 10. 6 plus 4 is 10. Total is now equal to 10. Over down here, line 5. I equals I plus 1. 4 plus 1 is 5. Set that into the I over here. I is now equal to 5. Reevaluate this condition up here. Finally, this condition is equal to false. 5 is less than 5. And we get false. So once this condition is false, we no longer do the stuff over here, but just jump down to the end down here. Press next, line 6, and print out total. Total equals 10. So summary, while loop, similar to an if statement, except that you are going to reevaluate the condition afterwards and potentially do the body many, many times. The main thing to focus on here is how these variables were changing throughout each of those iterations. Whenever you have a while loop, your variables over here are going to be different in each of those iterations. And so you have to be paying attention to that. We only care about what the variable is at the very last iteration when you come down here and print the total. Yes?
Just to make sure, so is it that like it went until like I is 6, then the condition is false and then it turns, or is it that?
So up here, the question was, or at least the first part of the question was, will we stop when I is equal to 6? And the answer is that if we substitute 6 less than 5, that would in fact be false, so we would stop. But actually, we're stopping earlier than that. We're stopping when I is equal to 5 because 5 is not less than 5. This less than is a strict less than. And so we stop when I is exactly equal to 5. If we change this from a strict less than I less than 5, we can make it less than or equal to in Python with the less than sign and an equals to like that. If I visualize the execution again, and I can press next a whole bunch of times to walk through it, or if I press the last button over here, it'll jump to the end. And now you can see that it did in fact run when I equals 5, went up here, checked is 5 less than or equal to 5, said yes, went through, and stopped when I was equal to 6 because 6 is not less than or equal to 5. Did that answer your whole question?
Yeah.
Question. Okay, good question. Any other question about the while loops so far? Okay, while loops. So I'm a relatively experienced programmer, and I run away from while loops. These things are evil and dangerous, and One of the signs of an experienced programmer is not just that you are able to like read and write complicated code, but you know when not to use complicated code, and while loops often create very, very complicated code. We saw that before of what's going to happen if I forget this line 5 down here. And so forget that line 5, visualize this execution, and we'll see what's going to happen. And you'll see there's a little red error message down here. So this is as the problem is printed in problem number 9. And now when I press next and go through here, we'll see that this I variable is never going to change. There's no statement down here where this I variable is going to change. No statement in that block where this I variable is going to change. And so every time we run through this loop, you can see that this I is never going to change. And so this is always going to evaluate to true. Down here, we never change I, so this is guaranteed to always evaluate to true. Keep pressing next, infinite loop happens, and we're stuck here forever. We can never get to this print total down here. So this is the reason why while loops are dangerous, because you can get these infinite loops, you can get this problem in your code, this bug in your code, and so there are certain situations where you really absolutely need to use a while loop, but we try to avoid it whenever possible. Instead of while loops, what's really common is that we will want to evaluate a certain piece of code a certain number of times. And we use for loops to do that. So if we scroll down here to problem number 13, 13 introduces the for loop. So total equals 0, for I in range, total equals total minus 1. Come back over here, edit this code. It's problem number 13, total equals 0. For I in range 5. For I in range 5. Total equals total minus 1. Total equals total minus 1. And then print total equals total. Anytime you see a for loop, you're guaranteed that the for loop is going to end. It can't run forever. And so that's why people, if you can use a for loop, you always want to use a for loop. What this for loop says is that this I value up here is going to take on all the values between 0 and 5, not including 5. So we're going to ignore this line right here, and we're just going to see what all the values of I is that it's going to take on. For I in range of 5, like this. And so at line 2 here, you can see there is no I variable anywhere in this global frame. If I press next, very first time we hit line 2, I appears in the global frame. And back up here, each time it's going to change. It started at 0, then 1, then 2, then 3, then 4. 4 is the last number that is less than 5. And so we're going to come up, the red arrow will go here, but we're not going to go inside this body, skip over it, and come down here to the end. So when you have this range of 5, you'll get 0, 1, 2, 3, 4, but you will not get 5. All of this information is in your cheat sheet. Let's go back to the cheat sheet here and review what we've done. All of this information, so we've talked about the math down here, all this Boolean logic, the things that you can do in Python inside of your conditions to make the truth and false values. There's if statements over here, we've talked about this. The conditional loop statement, this is the while loop, and now we're on the for loop over here. There's a lot of information in this for loop over here, but when it talks about for var in sequence, this thing that's a sequence, coming up, where's range? Integer sequences down here. These will tell you what numbers your range is going to get. So range 5, 0, 1, 2, 3, 4 as their example right here. If you have only one number in your range, you're going to get all the numbers starting at 0 up to, but not including this number over here. Again, the advantage of for loops, you will see for loops much, much more often than while loops. For loops cannot run forever, while loops can run forever. Any questions about that?
I have a question for the secret, I guess, for conditions on it. It wouldn't set the parentheses, I know you can add, say you can add 3 different ones for the starting, the ending, and then the how much, hypothetically. If you only have 2, would that mean would the first number be the ending and then the comma would be, how would that work?
Yeah, so the question is, this range function, one of the things that the pre-lecture videos talk about is that the range function, you can pass different arguments to it. It has different forms. So right here it says range 5, 0, 1, 2, 3, 4. If you pass 2 values to the range function, like 3, 8, the first value right here, the 3 in this case, is the start. And then the 8, the second value, is what you go up to, but not including. So range 3, 8 tells you 3, 4, 5, 6, 7. If we come back over here to our Python, edit this code, change that 5 to a 3, 8 like that, visualize the execution, then you'll see all of those values for I over here in this global frame spot. Press next, I equals 3, then 4, 5, 6, 7. Does not get to 8 because that's not included in the range that's listed right here. Let's change this back to range of 5 here, visualize execution. And let's just actually walk through it, not just about the I, but looking at total. Each time here we have total -1, so total starts at 0, and it's just going to get a -1 happening to it. We'll see that this line here is going to happen 5 times. That's why range does not include 5, because we want it to happen the exact number of times that is up here. And so subtracting 1 5 times gives us -5 like that. And so total equals -5. By the end of the course, you'll be able to look at this and not have to work through it step by step. You'll just know that total is going to be equal to -5. But certainly for this first quiz, while you're working on things, going through step by step is a great way to make sure you get the right answer. But if you want to just look at something and know that, okay, I know this is going to happen 5 times, so I'll just repeat this step 5 times and get -5, then that's okay to do as well. On Wednesday, again, so this is going to be where we'll pause for today. Wednesday, you'll have your quiz on CSS, not on this material at all. And I'll be here 10 minutes before the start of class. You can start taking your CSS quiz early. If this material that we were going over today felt like way too much going on, then make sure that you rewatch or watch for the first time those pre-lecture videos. And if this felt like way too easy for you, then we'll see things starting next time, but definitely next week, that will start getting more interesting. Anybody has any questions about anything, I will stay after class, but otherwise, see you all on Wednesday.